This short video tutorial contains abbreviated instructions on how to use FilmQAPro application to do a measurement-to-plan evaluation of a patient-specific treatment plan. It includes the steps of film calibration and calculation of a dose map from an exposed radiochromic film. The files used in this video are installed with the FilmQAPro application and are available in Program Files /Ashland Advanced Materials /FilmQAPro /image/example EBT3 Rapid Arc. Open FilmQAPro. There are three windows: the case data selector window on the left, the image window in the middle, and the analysis window on the right. The case data selector window contains the case tree, which is a compilation of tasks required to do an analysis. The last item in the case tree is the case data manager. Click the plus sign to expand it, and then click Add New Case Object, and select Film Calibration Ordinary from the pull-out menu. Click the plus sign to expand the calibration object, and then right-click Data Calibration Film Empty. For this demo, we're loading images from File, but this is where you could scan a film if you were connected to an Epson scanner. Now load the file calibration film 0_69_2, etc. The doses of the calibration films in centigrade are the numerals in the file name. We use 4 films here to demonstrate the one-scan calibration protocol, and if you follow the protocol you won't need lots of calibration points. In most cases just 3 are needed, because the asymptotic fitting functions in FilmQAPro behave like film and require only 3 coefficients to be defined. Adding an extra point or 2 helps by providing statistics on the goodness of the fit and allows you to identify bad calibration points and helps in selecting the best fitting function. Activate the frame selector tool and draw a region of interest in the center of one of the exposed areas. Repeat for the other 3 films, or, with the region of interest highlighted, hold down the Control key and point and click to add the other areas. At the bottom of the calibration object, click on the line Tool Calibration Tool to open the calibration in the analysis window, and then click the 1, 2, 3 icon in the bottom right corner to populate the calibration table with the response data. Right-click any data column to select the response value units, either 16-bit, density, or percent. Right-click the dose column to select the dose units. Enter the dose values. You can type them in any order, because the application will sort them in reverse order based on the 16-bit response value in the red channel. 16-bit response values for the films diminish with increasing dose. Alternatively, open the file exposures.txt in the same folder as the film images and copy and paste the doses in the dose column. The dose values are plotted and fitted to the function response equals A plus B divided by D minus C, where A, B, and C are the fitted coefficients, and D is the dose. Other functions are available for selection, but the reciprocal linear function is almost always best if the doses are less than 5 gray. Click the Statistics tab to display the consistency values for the various calibration functions. These figures of merit compare the actual calibration dose values with the function values for all 3 color channels and tabulate the differences. Lower values are better and help in selecting the best function. Now click Add New Case Object and add a dose map single scan object. Expand the object, right-click the line Data Dose Film Empty, select Open Image Dose Film from File, and then open the file Dose Film 0_313, etc. Soon as the file loads, calculations begin using the triple channel method. The button in the bottom right-hand corner turns blue to show that a calculation is in progress. As the calculations involve the solution of about 500,000 optimization problems, it could take anywhere from a few seconds to half a minute or more to finish. Upon completion, a thumbnail dose map appears in the dose map object. In this example, I'll show you the value of the one-scan dosimetry protocol. Click the dose map to show it in the image window, and then draw regions of interest on the two reference strips. Open the Statistics tab and look at the dose values for the two regions of interest. One is near 0, but the other is about 310 centigrade, nearly 1% difference from the reference dose used for exposure. The difference could be due to scan-to-scan variability of the scanner, or the temperature difference between the times the calibration films and dose film were scanned. In any event, if you stop here, you've just accepted a 1% offset in your measurements. So let's fix it. Return to the film image and draw small regions of interest in the middle of the reference strips, designating the areas as calibration regions, and enter the doses, 0 and 313 centigrade. Now we're going to rescale the calibration function and adapt it perfectly for this specific scan. In doing so, we're also recalculating the dose map. Right-click, Dose Map Single Scan, Dose Mapping Method, Recalibration using Reference Regions, and Dose Linear Scaling, and then re-click Dose Map Single Scan and Rebuild to recalculate the dose map. In a few seconds, the dose map refreshes. Now look at the dose values for the exposed reference strip. It's 313 centigrade in all three color channels. The reason the unexposed reference strip doesn't show 0 is because FilmQAPro resets any negative dose values to 0, so the values in the table are slightly positive, but statistically the distribution is correct. Now click on the Fiducial Management tool and highlight the fiducial marks delineating the position of the film relative to the treatment axes. Choose the general fiducial mark and then point and click over the pen marks on the film. Make fine adjustments by highlighting a mark, pressing Ctrl, and moving the mark with the keyboard arrows. Now let's add a dose-to-plan comparison object to the case tree, and we'll expand it when it appears. The dose map is already loaded. If you were working on a case with multiple dose maps, this is where you would have to pay attention to dependencies. Default is always to add the first dose map in the case tree. So if you want to work with a different dose map, you need to click on the line Dependence Dose Map Single Scan and select the correct dose map from the list. Then point and click the top line in the case object and select Open Image Treatment Plan from File and open the file ccw_cw, etc. You could also open a file with a format specific to one of several treatment planning systems by selecting Open Treatment Plan, or you could choose to open a treatment plan from a DICOM file. Now click on the line Tool Image Comparer to activate the Comparer tool and display the dose map overlaid on the treatment plan. If the dose map needs to be rotated or flipped to register with the plan, this is where you'd go to the toolbar and use the Flip and Rotate tool. But in this case, only translations and maybe a small rotation are needed. Activate the Fiducial tool and select Fit Fiducials horizontally, vertically, and rotationally to align the images. At this stage, the result of the gamma analysis shows more than 99.5% of pixels passing, with the default test criteria of 3% of 3 millimeters. However, these are quite coarse criteria, and a much sharper comparison comes from using a 2% to 2 millimeter test. Enter the new values in the tolerance and distance cells at the bottom of the analysis window. With this test, more than 90% of pixels are now passing. The analysis could be fine-tuned in a number of ways. First, by adjusting the size, shape, and position of the region of interest for the analysis. Also, by entering a 10% value in the minimum threshold cell to exclude from the analysis those doses less than 10% of the maximum. In doing this, the passing rate has fallen to about 89%. All translational and rotational shifts could also be made in the alignment to plan to compensate, amongst other things, for errors in marking the fiducials. One way to visualize these shifts is to use the IsoLines tab to display a plot of the dose distributions. In this example, the IsoLines plot shows the measurements, represented by thin lines, are shifted a small distance to the right of the plan, shown by thick lines. Now activate the Image Movements tool. Manual movement of the dose map is made using the large buttons for rotational and translational movements. The speed of movement is set from the Image Movement Speed icon. Click to toggle between coarse and fine motion, and refine the speed by using a setting from the drop-down list. Rotations are made relative to a user-defined rotation pole. Right-click the Image Movement icon and select Show Rotation Pole, and then Move Pole to Center Cross, which usually corresponds to isocenter and is often the best selection. Move the measurement image directly with the buttons, or click a button to activate it and then use the mouse wheel or keyboard arrows to make the changes. With gamma test criteria of 2% at 2 millimeters, the analysis is very sensitive to small changes in position and rotation, and with a few clicks of the alignment buttons, you'll see the passing rate at about 96%. Notice that the translational and rotational shifts are recorded in the cells alongside the movement buttons. The default unit for translational movement is pixels, but you can change this to length in millimeters. In this demonstration example, a rotation of half a degree and translations of 0.9 millimeters in X and 0.2 millimeters in Y increase the passing rate by about 7%. Investigate for yourself, and you'll find that with a 3% at 3 millimeter test, the passing rate changes by only about 1%, even for a 2 millimeter shift. Other features can be accessed using the tabs in the analysis window to display various charts and tables with analysis data, and any of these data can be added to a case report. Many of the display parameters, for example, axis ranges, line widths, display colors, etc., are automated or set by default. But if you right-click on any display near the axes of a chart or on a chart legend, the display settings can all be customized. The Profile tab displays profiles across a user-defined path. Click the profile icon in the toolbar to select the profile type and the width of the path. Move the path with the cursor, or for more precise control, click the path editing icon to display and then use all the profile path editing tools. Use the IsoMap tab to show a map of gamma values for a selected color channel, and the Map tab to display a map showing the location of pixels in each color channel failing the gamma test criteria. And use the Comparison Map Selector icon below any chart in the analysis window to select between differential delta, gamma, and distance to agreements maps. Then use the icons under the percent tolerance test criterion to select whether the tolerance is relative to maximum dose by default, relative to a user-defined dose, or relative to a local dose in the plan. Use the icon under the distance test cell to select the options for that criterion. Finally, in the Report tab, make a custom selection of the charts you'd like to see in the report. By default, all quantitative analysis data, gamma, distance to agreement, and differential delta, are included in the report. Select too the layout and number of charts per page, and specify for which color channels are charts to be included. If you've customized any of the charts in the report, click on the icon at the far right of the section. And if you changed any chart after specifying the contents and layout of the report, click the big red star to update. That concludes this short-form tutorial on using FilmQAPro to measure a dose distribution for comparison to plan. You've got the basics. But as with your Microsoft Office applications, there's a lot more capability to discover if you explore. Other video tutorials in this series give a more in-depth treatment of scanning, calibration, dose map calculation, and the dose-to-plan comparison.